All right, now we should be recording. So hello and welcome to the Spirent Test Center tutorial. In this particular video, we're going to be focusing exclusively on setting up some basic L2 connectivity between our Spirent ports. And this will cover both access and .1Q. And we're also going to look at not only how can we set up just a basic flow between two endpoints, but also just given how easy Spirent is, how we can get either a one-to-many or a many-to-many L2 flow between those endpoints. We'll also look at some additional configurations such as modifying our packet sizes or being able to send multiple QoS values or multiple streams all at the same time to assist on our recreates. So typical use cases you might see for this scenario is maybe you just need to send some volume of traffic through the switch. You really don't care what the endpoints are. You just need to send, say, 100 megs a second. Or if you're testing something, maybe you're configuring an ACL or a service policy, you need traffic that matches one flow and not another. Anything that involves packet counters or trying to increment something, maybe if you want to have the switch or router learn a large number of unique MAC addresses, all this stuff is going to be possible within this tutorial. So when we look at our desktop here, we're going to need a couple different things. One, I've got a switch over on the left that we're going to be testing with, and I've got two interfaces. I've got 101 and 102, which in this point are both configured in Access VLAN 10. I have my Kalo case here in which I've been given an RDP client as well as two pairs of ports. Now, the way it works out, normally when you check out interfaces for a Spirent, they're always going to be coming in pairs. So this is port 21 and port 22, but the way this particular example has been cabled, I'm using one port from each one of these pairs, but normally you'll just have the pair. And then on the right-hand side, I have my VM. Now, we are going to be using the Spirent Test Center, but one of the things that you'll see is we have a couple different versions available. I have version 4.69, 4.0, and 3.62. Very easy way to tell which one you're using is if you go to the ports you're going to be accessing, you have the chassis IP address right here. So I'm going to go ahead and copy that out. I'm going to open up an Internet Explorer or any sort of web browser, and you simply need to put in the IP address of the chassis you're trying to connect to. So in this case, I'll put in that IP, and it'll bring me to the Spirent page where it says that this chassis is running version 4.69. Now, if you ever want to download the application itself, maybe it's not on the desktop already, you could also click this link to download Spirent Test Center application, and you'll be able to control it from either your PC, a VM, etc. But in this case, now I know I'm going to be using 4.69, so I'll close that out and double-click the Spirent Test Center. Now, this will take a couple minutes to load, at which point we will need the IP address once again for this particular chassis. So just make sure, especially if you're using more than one interface, in this case I have two pairs of interfaces, make sure they're both on the same chassis just to help simplify things. So at this point, Spirent has now loaded. Now these are some of the quick start guides. We are not going to be using these, so we'll go ahead and close that out. And the first thing I want to do is click the top left, connect to chassis and reserve ports. When I do that, it'll ask me for a chassis to connect. If this option is not here, then you can click this connect/create, and then the first option, and that's where you'll put in your chassis IP address. But in this instance, that's already been done for me, so now I can open this up. Once we have our ports selected, we now need to go back to, or sorry, the port's open. Now I go back to Kalo and I look, I'll be using port 1, 3, and 4, and then 2, 1, and 2. And these are paired off. So when I look at slot 1 here and I select port 3, it's going to automatically set port 4 to be reserved. So generally speaking, these are in groups of 2. So I'll select those 2 ports, and then my next is going to be port 1 and 2. One thing that you may also see if you're running CDP, you may see the CDP information in the status here. But for now, I'm going to make sure all the ports I have checked out are ready to be reserved, and then we'll hit OK. At this point, it's now going to pull up the configuration and start syncing those and get them associated with my panel over on the left. So we'll see that port 1.3 and 2.2 are now coming online. Port 1.4 and 2.1 are not connected. Now the way Spirent works is I first need to define the endpoints on the various interfaces. Once my endpoints are configured, then I can create a traffic profile to send between them. So the first thing I want to do is I just want to click one of my interfaces. I'm going to click the Devices tab here, and this will bring me to this page. So I can now right click and I can add device, or you can use this add function right up here. So I'm going to go ahead and click add device, and it's going to pull up this wizard. Now in this case, because we're going to be configuring just basic one-to-one between two endpoints, I'm going to select the two ports that I want this traffic to be associated with. So 1.3 is automatically selected because that's where I was, and I want to make sure port 2.2 is also selected. So I'm going to have both of those configured. Now if you're using more than one port, you would make sure all the interfaces that you're actively using will be selected here. When I hit next, it'll now ask me what sort of protocol or what sort of device do we want to make this. The default is a traffic-only device. Essentially, you're telling Spirent, I just want you to be a dumb device that is just blindly sending and receiving traffic. Later on in some of the more advanced videos, we'll cover some of these additional options, but for now, we just want to accept the default. Once that's set, I now need to specify what type of endpoint is this. Is it going to be an IPv4 or an IPv6 endpoint, or maybe a dual stack capable? Both my interfaces in this example are also configured in access ports, so I am not going to configure any VLAN headers. However, if you are using .1q tagged interfaces, this is where you would enable this. But for now, I'm not going to do that. I'm going to select next, and now I have the option to say how many ports or how many devices do I want on each port. So the first part of this demo is going to be just a basic one-to-one mapping. So I'm going to say devices per port is 1, and now I can make up some of the information about that. So my IPv4 address might be 10.10.10.2. It'll be a /24. The gateway will be .1. The default setting for QoS is to set this to C0, so I'm just going to reset that down to 0. And then very important, we have the step over here. So the default setting is if you have more than one device per port, then we will increment this last octet by 1. If you have more than one physical port, then we'll increment the first octet. So if in this instance I want L2 connectivity between these two ports, I have two options. One is I can uncheck the step per port, or I can simply set it so that the step per port is incremented by 1. And this is usually the preferred option. That way everything will be incrementing linearly, and I'm not going to have any overlap. So I'm going to hit OK on that. And I also want to make sure, because I'm going to want to be configuring traffic soon after this, so I'm going to click this Launch Traffic Wizard so that once I'm done creating my endpoints, it'll automatically take me to the wizard that will navigate how to create traffic for me. So with all these settings now, I've got my steps set. I've got an IP address. I use the default MAC address, 1 device per port, and my step per device is 1 for the MAC address as well, so I'm not going to have any overlap. I'll go ahead and hit next, and now it's going to bring me to the final preview to make sure is my step and everything else, is it the way I expect? So we can see port 1.3 is going to have a client 10.10.10.2 with a MAC address ending in 1. It'll use .1 as the gateway, and port 2, same thing, but the MAC address and the IP address both increment by 1. So this is exactly what I'm looking for, so I'll go ahead and hit finish. The endpoints now get created, and then it pulls us into the traffic wizard. With this, we're going to follow pretty much the exact same steps. In this case, I'm going to deselect port 1, 4, and 2, 1 because those are not, I have no endpoints associated with those, so I'm keeping the same ports I did before. Going to hit next. And so now we get to configure what sort of traffic profile do we want. In this case, I'm going to say I want traffic going from port 1.3, and in this case, I only have a single device on 1.3, so checking either the device or the port, any one of these options selects everything all at once. So I'm going to want port 1.3 to talk to port 2.2. And then over on the left, do I want this to be unidirectional or bidirectional? Let's call it bidirectional for now. My endpoint mapping is a basic 1-for-1. That's perfect. So with those settings now configured, I'm going to click Add. And if I did it correctly, I'll see I have device 1, and then I have this sort of double ASCII arrow. So both directions are being pointed to, and then device 2. If for some reason this was unidirectional, so let's do 1, 3, and 2, 2, and I said unidirectional, if I added this, we would see it would only be the single ASCII arrow. Now, if you ever want to remove one of these, you can simply click it, get remove, and you'll be all set. So in this case, I accidentally removed my bidirectional, so I'll remove that, do the same thing. I want both ports, bidirectional, add, and that's going to be my flow. So now that we have the endpoints, now we need to tell Spirent what do we want this sort of traffic to look like. So I'm going to call it, give it a basic name. I'm going to call it 121. I want my frame size. I'm just going to do auto, just whatever the Spirent thinks is going to be the right size based on the number of headers I'm adding, etc. Just go ahead and do auto. If you want to configure various QoS fields, you're going to want to select this option here. So if I say vary protocol in QoS and then configure, and then hop over to the QoS tab, this is where I can now give it a list of different values to iterate over. So I might want to say I want a decimal value of TOS 46, right? Which may or may not be what I'm looking for. Maybe I want something like DSCP. But for this, we could just select diff serve, and then we could say, okay, I want to send some traffic that is going to be best effort. Actually, it looks like it didn't give me that. So let's do 0. So let's do this. So default is best effort. I want to add some of that. Or I might want to add some EF, some expedited forwarding. So that'll give me B8. And maybe I want to do something that is AF21, some sort of low latency type traffic. So now automatically, if I have these selected, Spirent will iterate over all three in the packet that I create. So I'll hit OK on that. And again, this is completely optional. You don't have to do that if we don't want to test QoS. And if you're, in this instance, I'm using 2 ports. Traffic is going to be going from port 1 to port 2. But if you only had a single interface and you wanted to have traffic, say, get hairpinned for some reason, then you would select the allow traffic to generate to itself. So I'm going to go ahead and click next, and now I get to create the frame itself. And a lot of this is going to be done automatically for me. So if I open up this IP header, we could see that there are some things like the total length is automatically calculated, my source and dest IP are all automatic, the protocol, everything is automatic. Now, if I need to specify a certain type of traffic, for instance, say UDP port 5000, this is where I can now edit that information. So within my actions here, I can add headers. Again, keep in mind this is all completely optional. As it stands now, we will, even without this option, we will create just basic L2 connectivity. But this helps to show a couple different options in the same video. So I'm going to select UDP, hit OK. Now I have a UDP header that I can open up and change some of my source and dest port info. So I could double click these in order to edit them. So I'll say 5000, and with this, I'm going to right-click Edit Value because the destination was automatically set, and I'm going to set this to 5000. And we'll see that the length, checksum, etc., everything should be automatically calculated once you make these changes. Now that I have the type of packet I want to send, I'm going to go ahead and hit Next, and I need to tell Spirent, how do we want to generate this traffic? And we have a couple different options. So starting up at the left is either port-based or load per stream block. The way this works, port-based means if I wanted to go through this process multiple times, what we're creating now is called a stream block. If I have multiple stream blocks, I can specify the individual rate that I want each one to take. So if I had one stream block that was just DSCP46, maybe I could set it to be 1 meg, whereas another one that was DSCP0 could be 50 meg. By doing port-based, we now set an arbitrary limit where all of our stream blocks, regardless of how many they are, will conform to a common rate. So in this case, I'm going to start by doing just the load per stream block. I want this to be rate-based, that's fine. My load mode, we have lots of different options here. So we could see that I can either increment, decrement, shuffle, or I can go through a list. So if you want to simulate either bursty traffic or traffic loads going up, going down, or just remaining fixed, all that is possible. I'm going to stick with fixed for now. My load unit, instead of doing a percentage of the interface, I want to specify frames per second. And I want to start this off with, let's just say 1,000 frames per second. That's a nice steady load, and everything else can remain as is. When I hit next, I now need to tell Spirent what interfaces will be receiving this traffic. So in this case, because it's a bidirectional flow, both port 1, 3, let's add that, and port 2, 2, to add that, both these interfaces will be receiving this flow, and then I hit finish. Now, what should be happening is I'll see my interfaces are green. That's good. If I go over to the traffic generator, it should now give me the stream I just created. And I can see here the name is one-to-one. If for some reason you have a long name, all these, we can expand these out. And I've got some of the settings that I configured through the wizard. So it's set to 1,000 frames per second. I can see my source and destination here. So lots of good stuff. Now, in this particular instance, the hosts were configured to ARP for one another. So before I start sending my stream, I need to right-click the stream, go over to ARP/ND, so ARP and Neighbor Discovery, and then select the first option. And assuming the switch is configured properly and we have connectivity between these two ports, once this configuration is done, the status should change from this kind of gray color to green. If for some reason your ARPs do not resolve, it will turn yellow, and you'll see a little status message comes up and says some ARPs failed to resolve, which may indicate that we have a network problem. But in this case, ARP for this client resolved correctly, so it turned to green. And if I go over to port 2, and let's go ahead and expand this one out, this is something that will work in, or need to be configured in both directions, potentially. So here we can see it also turned green. I could force it, I could just say start ARP and D as well on this particular flow, and everything should remain green, which is exactly what I want. Down below, once we started ARP, we now automatically started some interface statistics. So I could see for these interfaces, they both transmitted a total of 2 frames. One was the ARP request when I said send ARP, and the other was likely the ARP response to the other interface. I then got some basic bit counters, and if we scroll to the right, we could see that these set of options, looks like I lost my connectivity there, and we're back. So if I scroll to the right, we'll see there's actually quite a few different options we have. The vast majority of what we're going to be paying attention to is over on the left here. So now that I've got my clients and my traffic streams created, now it's time to start them. For that, it's very simple. Go to the flow that you want, right-click it, and then go to Start. And once I do this, I should see that now some of these counters will start changing and incrementing. So I could see here my total TX rate in bits per second is about 0.5 meg. If we scroll, let's see, we'll scroll through this, see if we can find what it is we're looking for. In this instance, my TX rate for this interface matches the RX rate, so that's a good sign. And if I scroll a little over to the left, we should be able to find something that maybe talks about packets per second. Let's see if we can find this, or maybe did I scroll past it? Let's see. Bits per second. Total frames. Here we go. So total TX rate in frames per second. So I can see right now port 2.2 is transmitting 1,000 a second, and port 1.3 is receiving at 1,000 a second. Now, this was a bidirectional flow, but the way Spirent is going to work, it only operates in one direction at a time. So if I want it to be bidirectional, I need to hop over to the other side and start that side as well. So when I start this, I should now see my total TX rate for the other interface will increment, and here we go. It's now at 1,000 packets per second, and the receiving is at 1,000. And if I look at my show MAC address table, VLAN 10, I should now see I have these 2 MACs learned for my 2 different interfaces. Now, one thing to note, if for some reason I want to make changes to this flow, generally speaking, there are some restrictions, but you can do certain things on the fly. For instance, if I want to go over to, say I want to increase this flow from 1,000 frames per second to 100,000, I could right-click my flow and simply go to Edit, and it'll pull up this information here. So I could see that I can modify, once my flow has been created, I can modify things like my frame size. I may be able to modify some of my destinations depending on what's been configured, or make adjustments to the frame itself. But for this, I want to go to the frames per second. I'm just going to add 2 extra zeros, and then refresh my rates, and hit OK. And when I do this, we should see that down here, my frame count really, it hasn't changed. And the reason for this, if you've used IXIA before, IXIA will automatically apply any configuration changes you make. Spirent does not. So in order for this change to now take effect, I need to stop my flow and then restart it. So if I right click and I stop my flow in this one direction, I'll now see my TX and RX rates drop. I can then right click, start, and when I restart the flow, it should now adopt my new frame rate that I configured. And so sure enough, my total TX rate in frames per second is now at 100,000 for both TX and RX, and the switch remains with its 2 MAC addresses learned. Now, one of the things that we could also do is we can also create multiple different streams that run simultaneously. So I've got my 2 clients here. Let's do a many-to-many scenario. Maybe I need 100 MAC addresses learned on one particular interface instead of just one. I could do that by clicking Add. I'm going to select my 2 ports again because I want this to be on both sides. I want a traffic-only device. I want this to be IPv4. And now my devices per port, I'm going to bump up to 100. The IPv4 address, I want to start at 10.10.10. Now remember before it was 2 and 3, so this will start at .4. It'll still remain a /24, toss value of 0, and I'm going to keep my modified step. So in this case, it's still step per device and per port are both incrementing the very last value. I'm going to select next and make sure everything looks good. So I can see it starts at 10.10.10.4, and if I scroll all the way down to the bottom, we could see, oh, it looks like there is, so it goes to 5. So I've got a little bit of an issue where I have a .4, 5, so we've got some overlap with our IP address. So one of the things that I could do is I can now modify my step, and I could say, all right, if I'm making 100 hosts, I want the step per port to now be offset by a value of, let's just say 102. So now it'll start 102 higher than it did before. And if I go next, I should now see the one port starts at 4, goes 5, 6, 7. That increments, goes up and up and up until we get to right about here. So we could see 100, 101, 2, 3, and then this is where now port 22, its starting IP address is 10.10.10.106, which is what I'm looking for. So now I know, okay, this IP addressing scheme, this is good, and my MAC addresses as well because of the way I configured the step. Here we could see it starts at 67, 68, so they'll all be unique MAC addresses. So I'll finish the device creation. I'm going to select No here as well. The default setting is asking you if you want to overwrite what you've already created, and I do not. I want to run these in parallel. I now select the 2 interfaces I want to send my newly created clients through. And so now I have a couple different options. I can still use the existing devices, but in this case, I want to use device 3 and 4, which are the 2 I just created. I want this to be bidirectional, and I want it to be many-to-many. I want a lot of hosts sending to a lot of other hosts, and I can hit Add. If for some reason you wanted this to be kind of a one-to-many, you could also do things like device 1 to device 4. And I can add this unidirectionally, and I can create a stream block that way. So we'll select this just to see what it does here. Select Next. I'll now call this many-to-many. Fixed frame size, I'm not going to do any QoS modifications. Hit Next. Basic IPv4 traffic, that's perfect for me. And I'm going to select the load per stream block. So keep in mind, my other one is now transmitting at 1,000 and 100,000 frames per second, respectively. Here, I'm going to set it 2 frames per second, and let's make it 5,000. I'm going to select Next, select the interfaces that could receive this flow, which is going to be the 2 active interfaces I'm using, and hit Finish. I do not want to overwrite my existing config. I simply want to merge it, so I hit No on that pop-up that came up. And so now I can see I have device 1 and 3 on this port. Over here is 2 and 4. If I go here, I can see I now have my many-to-many streams. So if I right-click this and start my ARP ND, it should now ARP out for the destination. Here it's just programming all those 100 hosts on either interface, so this typically takes a couple seconds. But once it does, as we saw before, it should now change my status light to green once the ARP resolution has completed. I'll also be able to see, because ARP is an L2 only frame, that once ARP resolution is complete, my MAC table should now increase on the switch. So we'll go ahead and we'll give this a minute to finish its programming. There we go. All right, and it did turn green, so my ARP resolution should have been successful. Let's go ahead and check our MAC table. There we go. So now I've got a lot more dynamically learned MACs across my various interfaces. So I've got quite a few learned on 101, some on 102, and that's what I was looking for. I can go down here. I've only got a one-to-one flow, so I'll go ahead and just do my many-to-many, and I will start this. And I should now see my TX rate bumps up because I was sending some existing traffic from the one-to-one flow as well as now my many-to-many flow. And if I go into the MAC table, we could see I now have significantly more MAC addresses learned in this particular subnet, all in VLAN 10. So that's going to be the end of this particular Spirent video. I hope you found it useful and can apply it to your recreates.